4. In problem number 4, we are going to calculate internal resistance now the problem will be based on internal resistance and terminal voltage calculation. The given is E is equal to 6 volt. The internal resistance is denoted by small r. It is given as 0.4 ohm. The load resistance RL is given as 2.6 ohm. From this we have to find current and terminal voltage. Now first of all, when we get such sort of problems, we should be able to draw basic circuit diagram from the given data. In solution, we will be first drawing a diagram which will be consisting of this E, which is given as 6 volt. Then the internal resistance, which will be in series with that. The R, small r, will be 0.4 ohm. Then you will be drawing the load resistance. RL is equal to 2.6 ohm. You should be able to draw this diagram, and the current flowing through this will be I. Now what we have to calculate? First we have to calculate the current. For the calculation of current, you have to first find out R equivalent is equal to R total of this circuit. In this circuit, as the internal resistance and load resistance are in series, we will find it as RL plus small r, because it is a series combination. In series combination, we have already learned the both resistors will be the summation of, means R total will be the summation of two resistors which are in series with each other. It is the series combination type of problem. Now 0.4 and 2.6 we will be getting as 2.6 plus 0.4 as 3 ohm. Now we have to calculate I, as this is a series circuit itself. Now we will be taking I is equal to E divided by R equivalent. The E is already given as 6 volt. The R equivalent, just now we have calculated it as 3. The answer will be 2 ampere. The current has been calculated. Now calculation of VT means terminal voltage. Now, where this terminal voltage will be? This is a node. Here, the VT we have to calculate. Now, VT, what terminal voltage will be? Terminal voltage will be nothing but E minus the current flowing through internal resistance or that circuit in I into small r. E will be 6 volt already given minus I will be, just now we have found out, 2 amperes into R will be 0.4. You will be getting as 6 minus 0.8, it will be 5.2 volts, the terminal voltage. Just now we have gone through internal resistance terminal voltage calculation. When the internal resistance with a battery E is given and the load resistance RL is given, how to calculate the current and terminal voltage from this problem. Actually, many times only the word problem or statement is given. Here we have to first create the circuit diagram for it. When you create circuit diagram, then go for calculation of current, then go for calculation of terminal voltage in a stepwise manner. This is the step 1, this is the step 2. Please write down carefully, as it will be asked for about 2 to 3 marks in examination. Please go through it. Now, very important concept in problem 5 we will be getting. The concept is when two cells, each of E equal to 1.5 volt and having internal resistance as 0.3 ohm, or you can say the R is equal to 0.3 ohm in parallel. Supply load R equal to 1 ohm. It is given. What we have to find is find total current and terminal voltage. Find total current and terminal voltage. Total current and terminal voltage. Now, first of all, we have to assume some things in this problem. Assumption and approach is very much important in this problem, because two cells are nothing but two batteries which are connected in parallel, you can say. Now we will draw a simple circuit diagram where I will be showing you what actually it is. This is the load resistance, which is 1 ohm already given. This is the internal resistance, which is given as 0.3, and it is also 0.3 ohm. And here the voltages are 1.5 volt and 1.5 volt. shown in figure, you will come across these two sets. This whole is one set, this is one the other set. This is the cell 1, this is the cell 2. Cell 1 and cell 2. Here you need to come across one concept which is very important. Please try to note down. When identical ideal cells with internal resistances are connected in parallel, positive to positive and negative to negative, this is the positive terminal, this is the negative terminal, positive terminal, negative terminal. If you see carefully, the negative terminal of these cells are connected to each other and positive terminals are connected to each other with the help of these internal resistances of their own circuit. Now, when such kind of situation takes place, the equivalent behave like a single cell with same EMF E and reduced internal resistance by a factor of n. Here, now the equivalent circuit I will draw. The equivalent circuit will be a resistance with a EMF and a load resistance. It will be reduced to this circuit. This is a circuit 1. You can say this is a circuit 2. It has been reduced to this circuit. Now, these resistances, internal resistance will become R divided by N. It will be same as E. Here the load resistance will remain same. Now, why this N, or from where this N came from? When two identical cells with internal resistances are connected in parallel, as positive terminal to positive terminal and negative terminal to negative terminal. EMF remains same, means E equal to E1 equal to E2, and small r, the internal resistance, R dash you can say is R divided by N. Here the value of N will be 2, as only two cells are connected in parallel. Note down this concept, which will be very helpful to you to solve such kind of problems, and even from theory point of view also, this is a very important concept which you should know as an electrical engineer, as you are going through diploma in electrical engineering, and even for other students also. Many times the syllabus for first year will be same. The fundamentals of electrical engineering is actually being taught to all the streams of electrical all the streams of engineering It may be computer engineer, mechanical engineering, civil engineering, or IT engineering, electronics engineering, instrumentation engineering, all streams which are being present in engineering core. They will be learning the fundamentals of electrical engineering, where the basic fundamental electrical engineering, the DC circuits, the AC circuits, the DC machines, the AC machines, the basic ideas should be clear to students. That's why I am going in detail, and I am trying to give my 100% in terms of theory as well as in terms of problems. So now the answer will be, the final figure will be the R by N. It is nothing but a 0.3. It is nothing but a R dash actually. I will first write it as R dash E and a resistance RL, where the R dash will be 0.3 divided by 2. It will be 0.15 ohm, and E will be already given as 1.5 volts. Now substitute in this, we will get as 0.15 ohm connected with 1 ohm. This is the EMF, which is 1.5 volts. Now you will find the current I total, which will be going through this. The IT is equal to 1.5 divided by the summation of this resistance as they are in series. You will find it as 1.5 divided by 1.15. It will be 1.3043 amps. And here you can see. Now what is asked again is terminal voltage. Now terminal voltage will be Vt is equal to the basic formula E minus I into small r. Now here we will be getting as 1.5 minus 1.3043 into R is 0.15. No, R is actually here, I can say R is R, yeah, that is correct. Just I have to make the double quoted, double bracket. Now we will be getting as 1.5 minus 1.043 into 0.115 as 1.03. Oh, sorry, 1.3043 volts as terminal voltage. Please go through the final answers. These are the final answers. Please note down how I have calculated. I have already shown you the basic formulas which I have been using. IT, you can still say as IT is nothing but E divided by small r plus RL. Here it is R dash in this case. In amps. And the I total into R. Again one concept I want to tell you. When this kind of circuit is formed, Here you can say the two cells are connected in parallel. That's why even if its EMF remains same, its current will be divided. Actually, the currents will be I dash will be I divided by N. Here it will be I divided by 2, means I total divided by 2. Now I cell 1 is equal to I cell 2 is equal to I total, just now we have got it as 1.3043 amps divided by 2. The answer will be somewhat 0.6521 0.6521 amps. Current through cell 1 and cell 2. Voltage remains same, but current gets divided. Note down each and everything. It will be very helpful to you in your upcoming examination, as well as your career gets proceed in electrical engineering. You will come across such kind of practical problems also, and this is nothing but a practical solution. How you are going to find out the current, the losses, the power loss, the resistors, the internal resistors, and what kind of loss is been taking place in our system. Now I will be cleaning this. Make sure you go through it in very detail and depth. It will be very helpful to you.